Alright, so let's go through the Trials of 2003 A Level question. So define SHM, right? So this one's simple. Just make sure that acceleration is directly proportional to your displacement. And the second part is the direction of the acceleration. Displacement must always be opposite in direction. So acceleration is, you can also say like acceleration is actually directed towards the equilibrium. So that is for the very first part. Okay, for part B, we are given this horizontal meter rule clamp at one end, then it's oscillating vertically as shown in the figure 1.1. Then again, we are given the velocity against your time graph. So definitely it's a cosine graph. So I can write down the formula V equal to 3 cosine omega t. So where omega is 2 pi divided by the period of 1.5 seconds. So that is the equation. So just remember the general equation. Okay. So the first part, we are asked to shade an area that represents the amplitude of the oscillation of the free end of the rule. So just think of one thing is that this is a VT graph. So the area under the graph will give you the distance. So means okay, let's just say I look at the very first part, 3 centimeter. So you can see that at time equal to 0, your velocity is the maximum. Means that you are at equilibrium. Then as you move, right, your velocity decreases until this part. So apparently, right, you can see that the velocity is 0. So means that at this part, right, you are at amplitude or the maximum point or minimum point. So the area under this must be the amplitude. Of course, not necessarily you must shade here. You can also shade here. So for example, I look at this part and look at this part. So this part is the amplitude or the highest point and lowest point. This part is the equilibrium. So you just need to shade this area from here to here. So this will be the amplitude. Okay, so let's move on to the next part. Part 2, determine the oscillation, the frequency, right? The frequency of the oscillation. This one is simple. You simply just use 1 over period, which is 1.5. So you do the calculation, is about 0.667 Hertz. Okay, number 2, what is the amplitude? The amplitude is not 3 because that one, the 3 right here, is actually what we call the maximum velocity. So how do I determine the amplitude? Very simple. So always go back to the formula. The maximum velocity is V equal to omega x naught. So I put V naught here. So V naught is 3, right? Then omega, we know all is 2 pi over period. Later we do the calculation, you'll be able to get your amplitude x naught. Okay. So let's do the calculation. So 3, right? Then my omega given to be as such 4.18879. So you do the calculation is about 0.716 centimeter. So that is for the second part. So don't need to write the centimeter because it's given to us. Okay, let's move to the last part. So the last part, we are asked to sketch your V against your so-called displacement graph. So definitely the shape will be an ellipse shape. So we must identify, where is my maximum velocity? So this is 3, this is -3. Where is our amplitude? Our amplitude is about here, 0.7. Due to the scale issue, I put at 0.7, then I put at -0.7. So these are the 4 points. Then you just need to draw in the clockwise direction. So of course, just think of one thing is that when you draw the ellipse, remember at this part and this part, the surface of the ellipse must be rather horizontal. Then at this part, so at this part and this part, try to make the ellipse, the surface of ellipse to be vertical. So that's how we actually draw the ellipse. So let's draw this together. So this one is here. So something like that. Not very nice, but that. Yeah, so yeah, not very nice. Of course, I believe you all can draw nicer. So this will be the Vx graph. So of course, the equation of this ellipse is given to be V equal to plus minus omega square root x naught square minus x square. So this is the equation. So try to memorize by heart.